This lesson is day 3 of Unit 3, Section 3. We are going back into Section 3.4. So today we're going to be using the quadratic formula to solve these, and we're going to have imaginary or complex solutions. So I'm going to still do all the same steps I did before. I'm going to find the discriminant, and if you remember, the discriminant is b squared minus 4ac. Right? I'm expecting this right now to be a negative number because we're dealing with imaginary numbers. So my a, this is already equal to 0. My a is 10. My b is 9. My c is 10. So b squared minus 4 times a times c is 81 minus 400, and that's negative 319. So that's what we were expecting, right? Because now we have imaginary solutions, two imaginary solutions. So the rest of my quadratic formula, if you recall, was negative b, or the opposite of b, plus or minus the square root of our discriminant all over 2a. So now we're going to have negative 9 plus or minus the square root of negative 319 all over 2 times 10. So I'm always going to simplify this in some way because I'm not going to leave the negative under the square root. So 319 itself does not go any further, right? There's no number that goes into 319 that it's a perfect square. So all I'm going to do is take out the negative as an I. So this is going to be negative 9 plus or minus I times the square root of 319 all over 2 times 10, which is 20. And that's my answer for this problem. There's nothing else to do. I'm not going to take the square root of 319. I can't simplify this any further. Nothing goes into 9, 1, and 20. So I'm done. Let's do another one together. So this one's not equal to 0 yet. So I'm going to start by adding 1 so that it's equal to 0. So now we have 7x squared minus 7x plus 9 equals 0. So that's an a value of 7, a b value of negative 7, and a c value of 9. So the discriminant, we have b squared minus 4ac. So that's going to be 49 minus 252. That's negative 203. So now I'm going to take the opposite of b, so negative negative 7, plus or minus the square root of my discriminant, negative 203, all over 2 times a. 203 again does not go any further. So I'm going to take the negative out as I, but I'm going to keep the 203 under the square root. And 2 times 7 is 14. Now, even though 7 and 14 do reduce, there's no number here with the I to reduce with it. If you remember, we can only reduce if all three things have something to take out. So this is actually done. It cannot be simplified any further. So you go ahead and try these two. You could pause it, and I'm going to show the answers. All right, so check your answers here. Couldn't go any further with either of these. So it stayed as 183, it stayed as 15, but the negative did come out as I, and I simplified the rest. All right. For the next one, again, not equal to 0 yet, so I'm going to add the 5 first. So that I have 5x squared minus 2x plus 5 equals 0. So a is 5, b is negative 2, and c is 5. So now I'm going to substitute in for my discriminant. So that's b squared minus 4ac That's 4 minus 100, or negative 96. So we're going to have opposite of b plus or minus the square root of negative 96 all over 2 times 5. So what's going to happen here is 96 does have things that go into it. And what we can do to find out what perfect square that's going to be, I know we already have negative 1 times the 96. But now I'm going to start to break down 96. And I look at, okay, well, we already know 96 is not it. So we're not going to bother with 1. Does 2 go into it? Yes. 2 times 48. 48 is not a perfect square. 3 goes into it 32 times. 32 is not a perfect square. 4 goes into it 24 times. 24 is not a perfect square. 6 goes into it 16 times. 16 is a perfect square. So this negative 96 is really negative 1 times 16 times 6. So the square root of 16 is 4, and the square root of negative 1 is I. So this is 4I root 6. So that's what's going to be replaced there. So in my next step, if I'm simplifying, I get positive 2 plus or minus 4I square root of 6 all over 10. And if I look at all three of these parts, they're all divisible by 2. So I'm going to divide all three pieces by 2. So that's going to be 1 plus or minus 4 divided by 2 is 2I root 6. And the whole thing is over 10 divided by 2, or 5. Okay, so we should be able to reduce them if they are reducible. Let's do another one together. Once again, not equal to 0 yet, so we're going to add the 9 first. So we have 6x squared plus 3x plus 9 equals 0. A is 6, B is 3, C is 9. So b squared minus 4ac, we get 9 minus 216 is negative 207. And even though it doesn't look like it, stuff goes into negative 207. So let's plug it into the quadratic formula first. So that's the opposite of b plus or minus the square root of negative 207 all over 2 times 6. So this negative 207, right, we already know is negative 1 times 207. And if I started making my list, we know 2 doesn't go into it, but 3 is 69, not a perfect square. 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, 7 doesn't go in, 8 doesn't go in, but 9 does, 9 and 23. 9 is a perfect square. So 23 I know can't go any further, right? There's nothing that goes into 23. So I know this pairing is the best I'm going to do. So the square root of negative 207 is really negative 1 times 9 times 23. So these two are 3 and I, 3I square root of 23. So that right there is going to get replaced with that. So x equals negative 3 plus or minus 3I root 23 over 12. And all three of these terms are divisible by 3. So I'm going to divide everything in the problem by 3. So that's negative 1 plus or minus I root 23 all over 4, right? 12 divided by 3 is 4. So this is my answer here. All right, you're going to try the last set, pause it, and I will show the answer. All right, so we get x is 5 plus or minus I radical 5 all over 10. And we get x equals negative 3 plus or minus I radical 2 all over 2. And that is our lesson for solving quadratics using the quadratic formula, getting imaginary solutions.